So these were the contents as I had told you yesterday. The first was the Oersted experiment. Second, the magnetic field, field lines. The fourth one, magnetic field due to a current carrying conductor. Fifth was magnetic field due to a current carrying straight conductor. Sixth, right hand thumb rule, magnetic field due to a current carrying conductor in a circular loop, a loop which is a conductor. Eighth, magnetic field due to a current carrying solenoid, uses of solenoid, force on a conductor carrying current, which is kept in the magnetic field, Fleming's left hand rule, and with the help of left hand rule we can learn about electric motor, then electromagnetic induction, the reverse process of electric motor, and Faraday's experiment, Fleming's right hand rule, electric generator, domestic circuits. Have you all written this?
Yes, sir.
Yes, sir.
Yes, sir.
Just we'll
Yes, sir.
see something, all of these, based on all of these, we'll see something now. So just to see, the first one I am going to show you on Oersted experiment. Girls, are you all present?
Yes, sir.
Yes, sir.
Just observe carefully. This is the Oersted experiment. Let me start it from the first. Can you hear any sound?
No, sir.
No, sir.
Yes,
No,
sir.
sir.
Can you hear?
No,
No,
sir.
sir.
No,
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 sir.
sir.
No, sir.
Sir, he has taken battery. He has connected. This is the key. This is the rheostat. Rheostat means it is the variable resistance. What you had written? Do you remember? This is
Yes,
the
sir.
variable resistance. Okay. So he has kept a compass. Can you see a compass here?
Yes,
Yes,
sir.
sir. Yes,
Yes,
sir.
sir.
So the red color shows the north pole and the black color shows the south pole. So north pole is also called as north seeking pole. North seeking pole, and the other one is called as south seeking pole. Means if you suspend a bar magnet in the air, our earth has got a big magnetic field. Means big bar magnet, they say that it has put inside the earth. So the magnetic side which moves towards the side north is called as north seeking pole. South is called as south seeking pole. Now let us see what experiment he did. He has connected a battery here and he has taken a wire and below it he has kept a compass. Just see what happens with the keys put here. Can you see when the current is flowing, the magnetic needle is showing deflection.
Yes, sir.
It was moving.
Yes, sir.
Yes, sir.
See, when they reverse the electric current, the direction of the current positive, they connected to negative, and the motion is also reversed. See, it is moving that side now. Earlier, it was moving towards the left side. See, see, it was moving this side. Then next, it was moving that side. So by this, he came to know that there will be a magnetic field when a current carrying conductor is present. If there is a conductor and it carries current, it will have a magnetic field around it. So the conclusion of this experiment is you have to write Oersted experiment, then you have to write the conclusion that a current carrying conductor will have a magnetic field around it. Write it down. What will you write? The current carrying
Current carrying
conductor
conductor.
will have a magnetic field around it. The current carrying conductor will have a magnetic field around it. Now let us understand what is this magnetic field. Okay, so he gave
Tell one more
by the first experiment the current carrying conductor will have a magnetic field around it. So the red circle, can you see around the wire there? Not only that part, everywhere throughout it, it will have magnetic field. Okay. Now, as you saw, this was Oersted experiment, which he told that there will be magnetic field. So first of all, we should know what is a magnetic field. This is what a magnetic field looks like. Yesterday, I had given a question of how iron fillings will act when they are brought near to the magnet. Can you see there? What are these lines? They are arranged in the form of line, no?
Yes, sir.
Yes,
They are
sir.
arranged in this form. Here to here, here to here, and here to here, here to here. Everywhere there are lines. See, these are all the lines, which we call as. So this is the field around it. This is the magnetic field around it. Where the object faces the force, it is called magnetic field. What is magnetic field? It is the location, it is the position near the magnet where the objects, metallic objects, the magnetic objects will feel the force. They will feel the force. It may be force of attraction or force of repulsion. Attraction andre ನೀವು magnet ಜೊತೆ ಆಟ ಆಡಿದ್ದೀರಿಲ್ಲ? Have you ever played with the magnet?
Yes, sir.
Bring one pole north and north near to each other, they will not attract. Attract ಮಾಡೋ ಬದಲು ದೂಗಿಸ್ತಾವೆ, ನೋಡಿದಿರಲ್ಲ?
Yes, sir.
Because they are like poles. North and north, if you bring near to each other, they will not attract, they will repel. But if you bring north and north to south ಎರಡು ಸಮೀಪ ತಂದ್ರೆ ಅಂಟುಕೊಂಡ್ಬಿಡ್ತವೆ. So the field which is near to it, where we feel this force, ಎಲ್ಲಿ force ಬರುತ್ತಲ್ಲ, attraction ಇರಲಿ, repulsion ಇರಲಿ, that region is called as magnetic field. The region in which the force is present is called as magnetic field. Did you understand now?
Yes, sir.
Yes, sir.
Okay. Now let us see. So these are the field lines. These are the field lines, and every field line will have their property. Field lines will have their properties. Have you written the properties of field lines yesterday?
Yes, sir.
Yes, sir.
Can anybody read? Here, Darshan, properties of field lines here, ನೋಡೋಣ.
The field is tangent to the magnetic field line. Second property, field strength is proportional to the line density. Third property, field
Line
lines
density.
are continuous loops.
Continuous loops. Now I will give you the properties. You can write this. Few other properties. Always field line starts at north pole. You can see here in the diagram, they are starting at the north pole and they are ending at
South
which
pole.
pole they are ending? South.
South pole.
South pole.
So one by one you write the property. First property is the field lines start at North Pole and end at South Pole, right? The field lines start at North Pole and end at South Pole. Second point, field lines has both magnitude and direction. So direction ಇದೆ, north to south direction ಇದೆ. Magnitude ಅಂದ್ರೆ ದೂರ ಹೋದ್ರೆ intensity ಕಡಿಮೆ ಆಗುತ್ತೆ, ಸಮೀಪ ಬಂದ್ರೆ intensity ಜಾಸ್ತಿ ಆಗುತ್ತೆ. So we can tell that it has, the field lines has both magnitude and direction. Second point. Did you write?
Yes,
Tell
sir.
one more time.
Field lines has both. Field lines has both magnitude, MAGNITUDE, and direction. If anybody doesn't understand anything, please ask. Don't sit quietly. I'll explain again. We are talking about magnetic field and field lines now. ಆಮೇಲೆ ಇದನ್ನ ವೈದ್ electricity connect ಮಾಡ್ತೀವಿ ನಾವು. The field lines has both magnitude and direction. Third point, they are in the form of continuous loop. They are in the form of continuous loop. They are in the form of continuous loop. The fourth point, the relative strength is the degree of closeness. The relative strength is the degree of closeness. Relative strength. Magnetic strength ಇರುತ್ತಲ್ಲ. If you hold a magnet 1 feet away from a pin, will it attract? ಒಂದ್ ಫೂಟ್ ದೂರದಿಂದ ಒಂದ್ ಯಾವ್ದೋ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಮೆಟಲ್ ಆಬ್ಜೆಕ್ಟ್ ಹಿಡಿದ್ರೆ ಅಂಟುಕೊಳ್ಳುತ್ತದು?
No,
Sir.
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 No, sir.
Because ನೋಡ್ಕೊಂತ ಹೋಗ್ರಿ ಇಲ್ಲಿ, just when you see the distance is different everywhere. You can see, ನೋಡ್ರಿ ಇಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಎಷ್ಟಿದೆ, ಇಲ್ಲಿ ಎಷ್ಟಿದೆ, ಇಲ್ಲಿ ಎಷ್ಟಿದೆ. The distance is increasing or decreasing?
Increasing.
ಅಲ್ಲಿ ಕೆಳಗೆ ಬರೆದ್ರಲ್ಲ, ರಿಲೇಟಿವ್ ಸ್ಟ್ರೆಂತ್ ಇಸ್ ದ ಡಿಗ್ರಿ ಆಫ್ ಕ್ಲೋಸ್ನೆಸ್. ಇಫ್ ದೇ ಆರ್ ಕ್ರೌಡೆಡ್, ಬರೀರಿ, ಕಂಟಿನ್ಯೂ. ಇಫ್ ದೇ ಆರ್ ಕ್ರೌಡೆಡ್, ಆರೋ ಮಾರ್ಕ್ ಹಾಕ್ರಿ, ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಅಂತ ಬರೀರಿ. ಕ್ರೌಡ್ ಇದ್ರೆ ಸ್ಟ್ರಾಂಗ್ ಫೀಲ್ಡ್ ಇರುತ್ತೆ. ಇಫ್ ದೇ ಆರ್ ಕ್ರೌಡೆಡ್, strong field. Not crowded, what is opposite of strong?
Weak.
Weak field. ಬಹಳ ಕ್ರೌಡ್ ಆಗಿರ್ಲಿಲ್ಲ ಅಂದ್ರೆ ವೀಕ್ ಫೀಲ್ಡ್ ಅಂದ್ರೆ ದೂರ ಹೋಗ್ತಾ 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 ಫೀಲ್ಡ್ ವೀಕ್ ಹಾಕೊಂಡು ಹೋಗ್ತೈತಿ. ಸೊ ಇಟ್ ವಿಲ್ ನಾಟ್ ಶೋ ಎನಿ ಫೋರ್ಸ್, ಯಾವುದನ್ನು ಜಕ್ಕೊಳಕ್ ಆಗಲ್ಲ. ಆದ್ರೆ ಸಮೀಪ ತಂದಾಗ ಜಕ್ಕೊಳಕ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾರೆ. How many points you wrote? 4 points, 3 points, sir?
4
Yes,
points.
sir.
4 points. 4. Fifth point. This is very important point. Very, very important point. No two field lines are found to cross each other. ನೋಡ್ರಿ, ಒಂದಕ್ಕೊಂದು ಟಚ್ ಆಗತ್ತ ಇವು ಫೀಲ್ಡ್ ಲೈನ್ಸ್. Are they touching each other? ಇದು ಹಿಂಗ ಬಂದ್ ಹಿಂಗ ಅಂಟುಕೊಳ್ಳೋದು.
No, no, sir.
It will not be like this. This is completely wrong. No two field lines are found to cross each other. No two field lines are found to cross each other. So example hingu question bandit last time ಒಮ್ಮೆ. What happens if two field lines cross each other? Suppose ನೋಡ್ರಿ, ಒಂದು ಡಯಾಗ್ರಾಮ್ ಹಾಕಿ ತೋರಿಸ್ತೀನಿ ನಿಮಗೆ. I will show a diagram. Suppose illon tagdini. Do you think the line I have drawn here is crossing two Other lines?
Yes, sir.
Is it crossing? So what happens? ಇಲ್ಲಿ cross ಆಗಿದೆ, ಇಲ್ಲೊಂದು compass ಇಡ್ತೀನಿ ನಾನು. Suppose if I keep compass, the magnetic needle has to show both the direction. North ತೋರಿಸ್ಬೇಕು, south ತೋರಿಸ್ಬೇಕು. Is it possible? ಒಂದು needle north south ಎರಡು direction ತೋರ್ಸಕ್ ಸಾಧ್ಯ ಇದೆ?
No, sir.
No, sir.
No, sir.
This is the answer. The question was, why two field lines do not cross each other? And question ಇತ್ತು. ಅದಕ್ಕೆ ಆನ್ಸರ್ ಏನು? If they cross each other, then at the intersecting point, the compass has to point towards north as well as south, which is impossible. ತಿಳಿತಲ್ಲ ಏನದು? The point of intersection, the compass has to point
North and
towards
south.
north as well as south, which is
South.
Impossible.
Impossible.
impossible. So ಇವೆಲ್ಲ field lines ಅಂತ. These are the field lines. I hope you understood. Magnetic field ಅಂದ್ರೆ ಅರ್ಥ ಆಯ್ತಲ್ಲ?
Yes, sir.
Yes, sir.
Magnetic field lines properties ತಿಳಿದು, these four properties important. They may be asked many times. Okay, now let us see how is the magnetic field in a straight conductor. Just observe that straight conductor. So just observe, nodri ಈಗ white paper they have kept and they have connected battery to it. In between they have put a conducting wire, thick conducting wire. So what happens now? Nodri, they are using a compass. ಯಾವ ಕಡೆ direction ತೋರಿಸ್ತಾ ಇದೆ, they are plotting. So you can see what type of circles are made here.
Concentric circle.
Can you see? These are called as concentric circles. What are concentric circles? All the circles have same center. Can you see same center for all circles?
Yes, sir.
Yes, sir.
Yes, sir.
What about radius? ಎಲ್ಲಾತ್ರದ್ದು radius same ಇದೆ, ಬೇರೆ ಬೇರೆ ಇದೆ.
No, sir.
ಬೇರೆ ಬೇರೆ.
ಬೇರೆ ಬೇರೆ.
So concentric circles are the circles with same center, different radius or different radii. ಗೊತ್ತಾಯ್ತಲ್ಲ, ರೇಡಿಯಸ್ ಬೇರೆ ಬೇರೆ. ನೋಡ್ರಿ ಸರ್ಕಲ್ ಹಾಕೊಂತ ಹೋಗಿತ್ತು. This is the field. ಆಗಲೇ ಮಾರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹೆಂಗಿತ್ತು ನೋಡಿದ್ರಲ್ಲ, ನಾರ್ತ್ ಪೋಲ್ ಸ್ಟಾರ್ಟ್ ಆಗಿ ಸೌತ್ ಪೋಲ್ ಬರ್ತಾ ಇತ್ತು. ಬಟ್ ಇನ್ ಸ್ಟ್ರೇಟ್ ಕಂಡಕ್ಟರ್ ಹೌ ಇಟ್ ವಿಲ್ ಬಿ? It will be in a form of concentric circle. ಈ ಡಯಾಗ್ರಾಮ್ ಹಾಕಿದಿರಲ್ಲ ನಿನ್ನೆ?
Yes, sir.
Yes, sir.
Yes, sir.
Below that or side ಗೆ ಬರೀರಿ ಅದನ್ನ. The conclusion of the experiment, the magnetic field in a straight conductor is in the form of concentric circles. Right? The magnetic field around a straight conductor are in the form of concentric circles.
Sir, please tell
ನೋಡ್ರಿ ಲೆಂತ್ ಇರ್ಕತ್ತೈತಿ. The magnetic field around a straight conductor are in the form of concentric circles. So can you see the arrow mark, red color arrow mark?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
ಅಂದ್ರೆ ಪಾಸಿಟಿವ್ ಟು ನೆಗೆಟಿವ್. When you were drawing circuit diagram, you remember arrow mark ತೆಗಿತಿದ್ರೆ ಇದೇ diagram. And now look at the circles. ಈ ಇದ್ರ ಮೇಲೆ arrow mark ಇದೆ. Can you see these arrow marks here?
Yes,
Yes,
sir.
sir.
Yes, sir.
Tell me, they are clockwise or anti-clockwise? Clockwise ಅಂದ್ರೆ ನಿಮ್ ಕ್ಲಾಕ್ ಹೆಂಗ್ ತಿರುಗುತ್ತಲ್ಲ, ಸೆಕೆಂಡ್ ಹ್ಯಾಂಡ್ ಅವರ್ ಹ್ಯಾಂಡ್ ಹೆಂಗ್ ತಿರುಗ್ತವೆ ಹಂಗ್ ತಿರ್ಗಾತಿತ್ತು ಇಲ್ಲ ಅದ್ರ ಅಪೋಸಿಟ್ ತಿರ್ಗಾತಿತ್ತು
Clockwise.
Opposite.
Clockwise.
Clockwise.
ಕ್ಲಾಕ್ವೈಸ್
Clockwise.
ದೇ ಆರ್ ಇನ್ ಕ್ಲಾಕ್ವೈಸ್. ಬಟ್ ರಿವರ್ಸ್ ಮಾಡಿದ್ರೆ ನೋಡ್ರಿ, ಈಗ ರಿವರ್ಸ್ ಮಾಡಿದ್ರಲ್ಲ ಪಾಸಿಟಿವ್ ಕೆಳಗೆ ಬಂತೀಗ. ಕೆನ್ ಯು ಸಿ ದ ಪಾಸಿಟಿವ್ ಹಿಯರ್?
Yes, sir.
Sir.
Yes, sir.
ವೆನ್ ದ ರಿವರ್ಸ್
Yes, sir.
ಲುಕ್ ಎಟ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ಈಗ ನೋಡ್ರಿ, now it is clockwise or anti-clockwise?
Anti-clockwise.
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 So we can tell that the field lines will have direction also. Direction ಇದೆ ಅಂತ ಗೊತ್ತಾಗುತ್ತೆ. So how to know the direction? Direction ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ ಏನ್ ಮಾಡಬೇಕು? Okay, let us see. To know the field lines direction, we have this rule called as
Right hand thumb rule.
Right hand.
Right hand thumb.
right hand thumb. With the help of right hand thumb rule, we will know how the direction. All of you hold your pen ಕೈಯಾಗ ಹಿಡ್ಕೊಳ್ರಿ. ಇವ್ರು ಹೆಂಗ್ ಹಿಡ್ಕೊಂಡಾರಲ್ಲ ರಾಡ್ ಹಂಗ್ ಹಿಡ್ಕೊಳ್ರಿ. The thumb has to point towards your nib ಇರ್ತೈತಲ್ಲ, ಪೆನ್ನಿನ ನಿಬ್ ಕಡೆ ನಿಮ್ಮ ಥಂಬ್ ಬರಬೇಕು, ಹಂಗೆ ಇಟ್ಕೊಳ್ರಿ. Now your thumb represents the direction of electric current. Current ಯಾವ ಕಡೆ ಹೋಗ್ತಾ ಇದೆ ಅಂತ ನಿಮ್ ಥಂಬ್ ತೋರಿಸುತ್ತೆ. Okay, and your other fingers, you have rolled your other fingers, no, ಹೆಂಗ್ ರೋಲ್ ಮಾಡಿದಿರಲ್ಲ ಆ ಡೈರೆಕ್ಷನ್ ದಾಗ ಕರೆಂಟ್ ಇರ್ತೈತಿ. In that direction, the magnetic field will be. Thumb represents the flow of current, and the other fingers which are rolled, they show the direction of magnetic field. Nodri, illet concept ನೋಡಿ. This is the direction of current, isn't it? Current ಈ ಕಡೆ ಹೊಂಟಿದೆ ಇಲ್ಲೋ, ಆರೋ ಮಾರ್ಕ್ ಹಾಕಿದೆ.
Yes, sir.
Yes, sir.
Yes, sir.
Now this is the direction of magnetic field. ಈ ಕಡೆ magnetic field ಇದೆ. Can you see this? Now if you take it
Yes,
below, left side ad nodri, the direction of current is like this, isn't it? And the direction of nodri, direction hengide, it shows like this in the reverse direction. It shows in the reverse direction. So ನೀವು ಏನ್ ಪೆನ್ ಹಿಡ್ಕೊಂಡಿದ್ದೀರಿ, thumb represents the direction of electric current, and the other fingers which are rolled, they show the direction of magnetic field. ಆ ಕಡೆ magnetic field ಇರುತ್ತೆ. Suppose ಈಗ ಪೆನ್ ನಿಬ್ ನೀವು ಕೆಳಗೆ ಹಿಡ್ಕೊಳ್ರಿ, ಪೆನ್ ಬುಕ್ಕಿಗೆ ಹಚ್ಚಿರಿ ನಿಬ್ ಹಂಗೆ ಹಿಡ್ಕೋಬೇಕು. ಥಂಬ್ ಅದಕ್ಕೆ ಕೈ ಇರ್ಲಿ ಥಂಬ್ ಇರ್ಲಿ, ಕೆಳಗೆ ಹಚ್ಚಿರಿ ಅದಕ್ಕೆ. The current is going inside your notebook now. Current ಹೆಂಗ್ ಹೊಂಟಿದೆ?
Inside our notebook.
Going inside the notebook. Going inside. How is the magnetic field? Magnetic field ಮ್ಯಾಲಿಂದ ನೋಡ್ರಿ ನಿಮ್ದು ಉಳ್ಕಿದ ಫಿಂಗರ್ಸ್ ನಿಮ್ದು ಕ್ಲಾಕ್ ವೈಸ್ ಇದೆನೋ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಇದೆನೋ?
Clockwise.
Clockwise.
So the current is
Clockwise.
going inside your book. The direction of magnetic field is clockwise. ಉಲ್ಟಾ ಇಡ್ರಿ, ಈಗ ಮ್ಯಾಲ ಇಡ್ರಿ. So your thumb represents above. The current is coming out of your book. Book ಇಂದ ಹೊರಗೆ ಬರ್ತಾ ಇದೆ. What about the direction ಹೇಳ್ರಿ ಈಗ magnetic field?
Anti-clockwise.
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 ಆಗಲೇ ಆ ಎಕ್ಸಾಂಪಲ್ ದಾಗು ಹಂಗೆ ಬಂತಲ್ಲ, ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಮಾಡಿದ ತಕ್ಷಣ ಕ್ಲಾಕ್ ವೈಸ್ ಹೋಗಿ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಆಯ್ತು. ಕೆಳಗಿಂದ ಮ್ಯಾಲ ಕರೆಂಟ್ ಬಂದಾಗ ಆಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ಆಯ್ತು, ಮ್ಯಾಲಿಂದ ಕೆಳಗೆ ಕರೆಂಟ್ ಬಂದಾಗ ಕ್ಲಾಕ್ ವೈಸ್ ಆಯ್ತು. So if a current carrying straight conductor is imagined to be held in the right hand such that the thumb points to the direction of the current, then the curled fingers of the hands indicate the direction of magnetic field. You can see direction. ನೋಡ್ರಿ ಈಗ ಮ್ಯಾಲ ಹಿಡ್ದಿದ್ರಲ್ಲ, ಮ್ಯಾಲ ಹಿಡ್ದಾಗ ಈಗ ಆಂಟಿ ಕ್ಲಾಕ್ವೈಸ್ ಆಗಿತ್ತು ಇಲ್ಲ, ಬುಕ್ ಒಳಗಡೆ ಹಿಡ್ದಿದ್ರಿ, ಯು ಆರ್ ಹೋಲ್ಡಿಂಗ್ ಟುವರ್ಡ್ಸ್ ದ ಬುಕ್, it was clockwise.
Yes, sir.
So any doubts in the right hand thumb rule? Any doubts in right hand thumb rule?
No, sir.
ಬಲಗೈದಾಗ ಹಿಡಿಬೇಕು ಮತ್ತೆ ಎಡಗೈದಾಗ ಹಿಡಿಬಿಟ್ರೆ ಊಟ ಆಗ್ತೈತಿ. ಹಾ, any doubt?
No, sir.
ಈಗ ಸರಿಯಾಗಿ tomorrow I will explain it once again on the board. ಕರೆಕ್ಟ್ ಆಗಿ ಏನಾದ್ರು ಪಾಯಿಂಟ್ ಇದ್ರಾಗ ಏನ್ ಮಿಸ್ ಆಗ್ತವೆ ಅದನ್ನ ನಾಳೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನಾನು. I will explain it again. Now observe and learn it properly. Okay, next is magnetic field due to a current carrying circular loop. In a circular loop, let us see how this circular loop right. So then I will start. See, this is a straight conductor. It's straight idodilla. This is straight. Now what happens if it is circular? ತೋರಿಸ್ತಾರೆ ನೋಡಿ. This is called a circular loop. Can you see circular loop there?
Yes, sir.
See how are the field lines ನೋಡ್ರಿ ಹೆಂಗ. So this is the diagram we have drawn yesterday. ಚಿತ್ರ ತೆಗ್ದಿರಿ.
Yes, sir.
Yes, sir. Yes, sir.
See, iron fillings are being poured. Iron fillings pour ಮಾಡಿದ್ರು. Current is allowed to pass. ಸ್ವಲ್ಪ ಟ್ಯಾಪ್ ಮಾಡಿದ್ರು. Can you see the shapes? Here you can see concentric circle. ಅವೇ circle ದೊಡ್ಡ ಹಾಕೊಂತ ಹೋಗಿದಾವ ಅಷ್ಟೇ. You can see here concentric circles. See both the side. But as they come near and near, can you see there? ಸಮೀಪ ಬಂದಂಗ ಹತ್ರ ಬಂದಂಗ ಹಿಂಗ್ ಸ್ಟ್ರೇಟ್ ಲೈನ್ ಆಗಿದೇನೋ ಇಲ್ಲ ಇಲ್ಲಿ. It has formed straight lines here.
Yes, sir. Yes, sir.
Yes, sir.
Yes.
Observe. Bigger and bigger, and at the center they look like a straight line. Everywhere ಎಲ್ಲ ಕಡೆ ಇರ್ತೈತಿ. ಇದು ಬರೀ ಆ ಪಾಯಿಂಟಿಗೆ ಅಷ್ಟೇ ತೋರಿಸಿದ್ರು ಅವರು. ದ ಫೀಲ್ಡ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್ ಎವ್ರಿವೇರ್. ಅವು ಕಾಯಿಲ್ ಎಲ್ಲೆಲ್ಲಿದೆ, ವೈರ್ ಎಲ್ಲೆಲ್ಲಿದೆ, ಎಲ್ಲ ಕಡೆ. So this is the right hand thumb rule. ರೆಸಿಸ್ಟೆನ್ಸ್ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ ಫೀಲ್ಡ್ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತೆ, ಸರ್ಕಲ್ ಹೆಚ್ಚಿಗೆ ಆಗ್ತಾವೆ when the current is more. So one circular coil ಇಂದ ಒಂದು ಫೀಲ್ಡ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಯ್ತು. What happens if the number of loops are increased? ಆ loops increase ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಕಡಿಮೆ ಆಗುತ್ತಾ ಹೆಚ್ಚಿಗೆ ಆಗುತ್ತಾ? ಈಗ
ಹೆಚ್ಚಿಗೆ.
ಒಂದು ಕ್ಯಾಂಡಲ್ ಹಚ್ಚಿಟ್ರೆ ಎಷ್ಟು ಬೆಳಕಾಗುತ್ತೆ? If I lamp 10 candles, the brightness will be more or less?
More.
More.
Similarly,
More.
the loops are more. See, they have given, if there are n turns in the loop, the magnetic field produced would be n times larger than that produced by a single loop. One loop, one time magnetic field produce ಮಾಡಿದ್ರೆ ನೀವು 10 loop ಮಾಡಿದ್ರೆ 10 times increase ಆಗುತ್ತೆ. 20 loops ಮಾಡಿದ್ರೆ 20 times increase ಆಗುತ್ತೆ. Isn't it? Okay, let us see about a solenoid now. Where is solenoid? The number I clicked it in ಎಲ್ಲೆಲ್ಲೂ ಕಾಣ್ತಿದೆ. Okay, here. First, write what is solenoid. Have you written the answer solenoid yesterday? What is a solenoid and ಕೊಟ್ಟಿದ್ದೆ? An insulated copper coil is wound around some cylindrical board. Such type of formation is called as solenoid. ನೋಡ್ರಿ ಇಲ್ಲಿ ಹೆಂಗ್ ಮಾಡಿದ್ದಾರೆ? The coil is wound around a cylinder. So it behaves like a magnet, on bar magnet form ಆಗಿಬಿಡ್ತಿತ್ತು. It forms a bar magnet now. Clockwise direction, the current is flowing. See, it became south pole when the current is passed through in this solenoid from in the direction clockwise direction. So the left side becomes south pole, right side becomes
North Pole.
right side ಯಾವ pole ಆಗುತ್ತೆ? North pole.
North Pole.
Current is reversed. ಈಗ reverse side current, anti-clockwise current pass ಮಾಡುತ್ತೆ. So which side becomes south now? Right side or left side?
Right side, sir, south. Right side.
So this solenoid converted into a bar magnet. So it becomes a bar magnet now. So solenoid behaves like a bar magnet. Solenoid increases, then the magnetic effect also increases. Is it same? ನೋಡ್ರಿ ಎರಡು diagram same ಕಾಣಿಸುತ್ತಾ ಇಲ್ಲ ಈಗ? Means the solenoid becomes a bar magnet if sufficient current is passed through the coil. A solenoid. Now what are the uses of solenoid? Have you written the uses of solenoid?
Sir, solenoid means?
Solenoid means ಅದೆಲ್ಲ cylinder shape ಮಾಡಿದ್ರಲ್ಲ ಅವರು. The cylindrical shape they had made.
Yes,
A
sir.
cylindrical circular coil ಮಾಡಿದ್ರಲ್ಲ, that is called solenoid.
Yes, sir.
These are the applications of solenoid. ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ನೋಡ್ರಿ. The main use of solenoid is as a switch for power. They are used in indicator, walls, antennas, etc. It is used to control a wall electrically. ನಾವು ಹೋಗಿ ಈಗ ಮನಿ ಒಳಗೆ ನೀರು ತುಂಬಂದ್ರೆ ವಾಲ್ ಬಂದ್ ಮಾಡ್ತೀವಲ್ಲ, ಮಾಡ್ತೀವಿ,
Yes, sir.
Yes.
ಚಾವಿ ಬಂದ್ ಮಾಡ್ತೀವಿ, ನಳ ಬಂದ್ ಮಾಡ್ತೀವಿ. ಸಿಮಿಲರ್ ಟು ಇಟ್, ಎಲೆಕ್ಟ್ರಿಕಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ವಸ್ತುನ ಆನ್ ಆಫ್ ಮಾಡ್ಬೇಕಂದ್ರೆ, ಇಫ್ ಸಮ್ ಕೆಮಿಕಲ್ಸ್ ಆರ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ಇಟ್, ಇಫ್ ಸಮ್ ಗ್ಯಾಸಸ್ ಆರ್ ಫ್ಲೋಯಿಂಗ್ ಇನ್ ಇಟ್, ಎಲೆಕ್ಟ್ರಿಕಲಿ ಎಲ್ಲೋ ಮ್ಯಾಲ ಹಾಕಿರ್ತಾರೆ ವಾಲ್, ಇಂಡಸ್ಟ್ರಿದಾಗ ಮ್ಯಾಲ ಎಲ್ಲೋ ಒಂದು 50-60 ಫೀಟ್ ಮೇಲೆ ಹಾಕಿರ್ತಾರೆ. ಅಲ್ಲಿ ಒಬ್ಬೊಬ್ರು ಮನುಷ್ಯರಿಗೆ ನಿಚ್ಚಲಿಕ್ಕೆ ಇಟ್ಕೊಂಡು ಹೋಗಿ ಬಂದ್ ಮಾಡಕ್ ಆಗಲ್ಲ. ಸೊ ದಟ್ those places they use solenoid valves. So switch ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಇರ್ತೈತಿ, ಸ್ವಿಚ್ ಅಲ್ಲಿ ಆನ್ ಮಾಡಿದ್ರೆ it will allow the chemical to pass through, ಆಫ್ ಮಾಡಿದ್ರೆ it will stop the chemical. They are used in computer printers. Computer printers also they are used. ಎಲ್ಲಿ ಎಷ್ಟು ಇಂಕ್ ಬೇಕು ಅಲ್ಲಷ್ಟೇ ಇಂಕ್ ಕಳಿಸುತ್ತದು. So they are the valves on off. Even solenoids are used in fuel injection gears in cars. ಕಾರ್ ಒಳಗಡೆ ಫ್ಯೂಯಲ್ ಇಂಜೆಕ್ಟರ್ಸ್ ಇರ್ತವೆ. ಆ ಇಂಜೆಕ್ಟರ್ಸ್ ಆರ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ವಾಲ್ಸ್. ದೋಸ್ ವಾಲ್ಸ್ ಆರ್ ಮೇಡ್ ಅಪ್ ಆಫ್ ದೀಸ್ solenoids. Even solenoids are used to manufacture magnets. ನಿನ್ನೆ ಹೇಳಿದ್ನಲ್ಲ, magnet we you have for earphones, speakers, how they are manufactured? They are manufactured using the solenoid. Solenoid ಒಳಗೆ ಜಾಗ ಇತ್ತಲ್ಲ, ಆ ಜಾಗ ಒಳಗಡೆ ಹಾಕಿಬಿಡ್ತಾರೆ. They will put the soft metal inside. ಒಂದು ಸಾಫ್ಟ್ ಐರನ್ ಮೆಟಲ್ ಹಾಕಿಬಿಟ್ರೆ, after some time if you remove it out, it becomes and behaves like a magnet. Unmagnet ಆಗಿಬಿಡುತ್ತೆ. Not permanent magnet, it is an artificial temporary magnet. For some years it behaves like a magnet. ಗೊತ್ತಾಯ್ತಲ್ಲ uses of solenoid. Now the question comes, how is the magnetic field inside the solenoid? Solenoid ಒಳಗಡೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹೆಂಗಿರುತ್ತೆ? ಹೊರಗಂತೂ ಗೊತ್ತಾಯ್ತು, ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಸೌತ್ ಪೋಲಿಗೆ ಬಂತು. ಹೌ ಇಟ್ ಈಸ್ ಇನ್ಸೈಡ್, ಒಳಗಡೆ ಹೆಂಗಿತ್ತು? That is the question which was asked in the examination. How is the magnetic field inside a solenoid? Even in bar magnet, ಹೆಂಗ್ ನಾರ್ತ್ ಪೋಲ್ ಇಂದ ಫೀಲ್ಡ್ ಲೈನ್ ಸೌತಿಗೆ ಹೋಗ್ತಲ್ಲ, ಮ್ಯಾಗ್ನೆಟ್ ಒಳಗಡೆ ಸೌತ್ ಇಂದ ನಾರ್ತಿಗೆ ಹೋಗ್ತಿರ್ತಾವ. ಒಂದು ಪೈಪ್ ಇದ್ದಂಗ, ನಾರ್ತ್ ಟು ಸೌತ್, ಸೌತ್ ಟು ನಾರ್ತ್, ನಾರ್ತ್ ಟು ಸೌತ್. ನಾರ್ತ್ ಟು ಸೌತ್ ಹೊರಗಡೆ, ಮ್ಯಾಗ್ನೆಟ್ ಒಳಗಡೆ ಸೌತ್ ಟು ನಾರ್ತ್. ಸಿಮಿಲರ್ಲಿ ಇನ್ ದ ಸೊಲೆನಾಯ್ಡ್ ಆಲ್ಸೋ, ಸೊಲೆನಾಯ್ಡ್ ಒಳಗಡೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಹೆಂಗಿರುತ್ತಂದ್ರೆ ಇಟ್ ಈಸ್ ಯೂನಿಫಾರ್ಮ್. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಚೇಂಜ್ ಆಗೋದಿಲ್ಲ, ಇಟ್ ಈಸ್ ಯೂನಿಫಾರ್ಮ್. So that was all about a solenoid. Now comes the question, if the direction change ಮಾಡಿದಕ್ಕೆಲ್ಲ ಚೇಂಜ್ ಆಗ್ತಾ ಇದೆ, can we generate force from this? Can we generate force? Let us see how do we generate the force from it. Here is an experiment. Force on a current carrying conductor in a magnetic field. Can it generate any force? Here is the setup. Iddu diagram ittalla nimdu. You had this diagram?
Yes, sir.
Yes, sir.
Force. You can see AB is a metal. One yavado magnetic metal ಇದೆ. It can be attracted towards the magnet. Okay, it is a conductor. It is connected to the battery. Battery connect ಆದ ಕೂಡಲೇ ಏನಾಗ್ಬಿಡುತ್ತೆ, AB becomes magnet now because it will have magnetic field around it. ನೋಡ್ರಿ ಮುಂದೆ ಏನಾಗುತ್ತೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್. So they have brought a magnet here. ಯಾವ magnet ಅಂತೀವಿ ಇದಕ್ಕೆ? What type of magnet it is? ಈ ಶೇಪ್ ಎಲ್ಲಾದ್ರೂ ನೋಡಿದಿರಿ ನೀವು? Have you seen this shape anywhere? ಕುದುರೆ ಕಾಲ್ ನೋಡಿದಿರಿಲ್ಲ?
Yes, sir.
Sir.
Yes, sir.
ಅದಕ್ಕೆ ನಾಲ್ಕು ಬಡಿತಾರ ಗೊತ್ತು.
Yes, sir.
Yes, sir.
Yes.
ಮೆಟಲ್ ಸೇಮ್ ಹಂಗೆ ಇಲ್ಲ ಇದು.
Yes, sir.
ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್
Yes,
ಹಾರ್ಶೋ ಮ್ಯಾಗ್ನೆಟ್.
Yes, sir.
ಇದಕ್ಕೆ ಏನಂತೀವಿ? ಹಾರ್ಶೋ ಮ್ಯಾಗ್ನೆಟ್.
Horseshoe magnet.
ಹಾರ್ಶೋ HORSHOE. ಹಾರ್ಸ್ ಶೋ ಅಂದ್ರೆ ಶೂ ಇರ್ತೈತಲ್ಲ, ಶೂ ಟೈಪ್ ಹಾರ್ಶೋ ಮ್ಯಾಗ್ನೆಟ್ ಅಂತಾರೆ. ಸೊ ಲುಕ್ ಕೇರ್ಫುಲಿ ನೌ. We have a conductor here. This is a conductor and here we have a magnetic field. ಈಗ ಈ ಕಂಡಕ್ಟರ್ ಒಳಗಡೆ ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ? ಇಟ್ ವಿಲ್ ಹ್ಯಾವ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅರೌಂಡ್ ಇಟ್. ಫೀಲ್ಡ್ ಬರುತ್ತಂತೆ. Now see
Yes, sir.
what happens? It has a magnetic field now. Current bitre. Now they have connected to the battery. Battery connection ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಯ್ತು? It got magnetic field. Magnetic field positive ಮೇಲಿಂದ ಕೆಳಗೆ ಬರ್ತಾ ಇದೆ. This direction. Okay, this direction the current is flowing. ಆಯ್ತು. ಫಸ್ಟ್ ಈ ಕಡೆ ಇದೆನೋ ಈ ಕಡೆ ಇದೆನೋ. So the direction of the force is also reversed when the direction of current is passed. Okay, ನೋಡ್ರಿ ಏನಾಯ್ತು? When they switched on the current, ಆ ಐರನ್ ರಾಡ್ ಏನಿತ್ತಲ್ಲ, it is attracted towards south ಕಡೆ ಹೋಯ್ತು. ಡೈರೆಕ್ಷನ್ ಆ ಕಡೆ ಬಂದಿತ್ತು. ನಾವು if they reverse it, ಇದನ್ನ ರಿವರ್ಸ್ ಈ ಕಡೆಯಿಂದ ಕರೆಂಟ್ ಕೊಟ್ರೆ what happens? The direction of this will turn towards north side. ಆಗಲೇ ಆ ಕಡೆ ಹೋಗಿತ್ತು, ಈಗ ಈ ಕಡೆ ಬರ್ತಿದೆ. You see? Did you see? It came towards south side. ನೋಡಿದ್ರಿ ಇಲ್ಲ?
Yes, sir.
Yes, sir.
Yes, sir.
ಆಗಲೇ ಈ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಇದ್ದಾಗ when it was coming from this direction, it went towards north, but now the current is going towards this direction, it came to south.
Now,
ಸೊ ಇದನ್ನ ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಅಪ್ ಡೌನ್ ಮಾಡ್ಕೊಂತಿದ್ರೆ, ಕಂಟಿನ್ಯೂಸ್ ಆಗಿ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ, ಡು ಯು ಥಿಂಕ್ ಇಟ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ವೈಬ್ರೇಟಿಂಗ್? ಇದು ಈ ಕಡೆನೂ ಹೋಗುತ್ತೆ, ಈ ಕಡೆನೂ ಬರುತ್ತೆ. ಸೊ ಇಟ್ ವಿಲ್ ಸ್ಟಾರ್ಟ್ ಇಟ್ಸ್ ಮೋಷನ್. ಸೊ ಡಿಡ್ ವಿ ಜನರೇಟ್ ಫೋರ್ಸ್ ನೌ? ಸೊ ವಿ ಹ್ಯಾವ್ ಜನರೇಟೆಡ್ ಫೋರ್ಸ್ ಬಿಕಾಸ್ a current carrying conductor was kept in between the magnets. So by this we will come to the point of Fleming's left hand rule. Can you see which are the fingers here? Which are the fingers? Idu yav finger idu?
Thumb.
Which is this finger?
Index finger.
Index finger.
index finger.
Which is this finger?
Middle finger.
Middle finger.
Middle finger.
What is the angle between them?
90 degree. 90 degree.
So you should write, if you get the question like state Fleming's left hand rule, you should say the three names of the fingers. The three fingers of left hand, the thumb, the index and the middle finger, held mutually perpendicular to each other. You know? Mutually perpendicular to each other. Then the middle finger represents, in represent madadit middle finger is
Magnetic field.
Magnetic field.
Current.
middle finger current.
Correct.
The index finger
Magnetic field.
Magnetic field.
the thumb represents
Force acting
on
on the
Acting
conductor.
on the conductor.
don't forget these 3 points. In starting if the three fingers of left hand. The thumb, the index, and middle finger held mutually perpendicular to each other. How? Mutually
Usually perpendicular to each
Perpendicular.
Perpendicular to each other.
Then the middle finger represents
current.
Magnetic
Current.
Current.
current. Index finger represents
Magnetic
Magnetic
field.
field.
Magnetic
Magnetic
field.
field.
and the thumb represents
Force
Force
acting
acting
on the conductor.
Force acting on the conductor.
conductor. So this is the Fleming's left hand rule. So these are the three fingers. Can you see that? Nodri, ಮೂರು perpendicular ಇದಾವೆ. So with the help of this, we have the devices here. We have the devices here. What are these? ನೋಡ್ರಿ ಇವನ್ನೆಲ್ಲ ಹೇಳ್ರಿ ಇದೇನಿದು?
Mic.
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 Microphone. It is a microphone. Next, these are speakers. This is a motor. ಇದು ಒಂದು lathe machine type. Okay, this is ಏನದು sound tracking device. Which ಇದು multimeter. We can measure different types of measuring devices. So these are all working on the principle of Fleming's left hand rule. I will show you that. Left handed with the right hand thumb rule. Here it is. Fleming left hand rule. Can you see all the three fingers? When you keep the thumb, index, and middle finger on the left hand right angle to each other, if the middle finger shows the direction of current, index shows the direction of magnetic field, thumb shows the direction of motion. So this law explains the working of a motor. It may be DC or AC. It is a motor. Now let us see what is a motor. How a motor looks like. So this is a DC motor. ಮೋಟರ್ ಯೂಸ್ ಮಾಡಿದಿರಿ ನಿಮ್ ಕಾರ್ ಒಳಗಡೆ ಇರುತ್ತಲ್ಲ ರಿಮೋಟ್ ಕಾರ್ ಅದು ನೋಡಿದಿರಿ ನಾವು
Yes,
Yes,
sir.
sir. Yes, sir.
Yes, sir. Yes, sir.
ಹೆವಿ ನಿಮಿಷ ಇದೆ ಏನೋ ಡಿಸ್ಕನೆಕ್ಟ್ ಆಯ್ತು for a second. Can you hear me?
Yes,
Yes,
sir.
sir.
Can you hear me? Okay, you have seen the motor, no? ಆಟ
Yes, sir.
ಆಡೋದು ಮೋಟರ್ ಯೂಸ್ ಮಾಡಿದ್ರಿ ನೀವು ವಿಂಡ್ ಮಿಲ್
Yes, sir.
ಮಾಡಿದ್ರೆ ಒಂದು ಸಣ್ಣ ಮೋಟರ್ ದಟ್ ಈಸ್ DC. ನಾನು ಎಲ್ಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ. ದಿಸ್ ಇಸ್ ದ ಸೆಟಪ್. ಈ ಸೆಟಪ್ ನಾಗ ಎಲ್ಲ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ. ನಾರ್ತ್ ಅಂಡ್ ಸೌತ್ ದಟ್ ಈಸ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. ನೀವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಅಲ್ಲೂ ಡಯಾಗ್ರಾಮ್ ಇದೆ. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಡಯಾಗ್ರಾಮ್ ಫಾರ್ ಯುವರ್ ಎಕ್ಸಾಮಿನೇಷನ್. ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದಾದ್ರೂ ಬೀಳುತ್ತೆ ಇಲ್ಲ ಜನರೇಟರ್ ಆದ್ರೂ ಬೀಳುತ್ತೆ. ಎರಡರಲ್ಲಿ ಒಂದು ಡಯಾಗ್ರಾಮ್ ಗ್ಯಾರಂಟಿ ಬೀಳುತ್ತೆ. ರೈಟ್. ಸೊ ನೋಡ್ರಿ ನಾರ್ತ್ ಸೌತ್ ಅಂತಿದೆಲ್ಲ ಕಾನ್ಕೇವ್ ಶೇಪ್ ಇದೆ. ಕಾನ್ಕೇವ್ ಶೇಪ್ಡ್ ಮ್ಯಾಗ್ನೆಟ್ಸ್ ಇದೆ. ಅದರ ನಡುವೆ ಕ್ಯಾನ್ ಯು ಸಿ ದ ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಶೇಪ್ ಹಿಯರ್?
Yes, sir.
ಅದಕ್ಕೆ ಆರ್ಮೇಚರ್ ಅಂತೀವಿ ನಾವು. ಏನಂತೀವಿ? ಆರ್ಮೇಚರ್. ಇಟ್ ವಿಲ್ ಇದರಿಂದ ಹಿಂಗ ಒಂದು ಕೇಬಲ್ ಹೊರಗೆ ಬರುತ್ತೆ. ಇಲ್ಲಿ ಹೊರಗಡೆ ಇಲ್ಲಿ ಫ್ಯಾನ್ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದಾರೆ. ವಿಚ್ ವಿಲ್ ಹ್ಯಾವ್ two rings. Can you see the rings here?
Yes, sir.
Yes, sir.
One ring is cut into two parts. One ring cut ಆಗಿ ಎರಡು ಪಾರ್ಟ್ ಆಗಿದೆ. So these are called as split rings. ಏನಂತೀವಿ ಇವಕ್ಕೆ?
Split rings.
Split rings.
Split rings. Split rings ಗೆ can you see some blurred ಇದೆ ಗೊತ್ತಿಲ್ಲ? Can you see a black colored point here?
Yes, sir. Yes, sir.
ಈ ಕಡೆನೂ ಒಂದಿರುತ್ತೆ, ಆ ಕಡೆನೂ ಒಂದಿರುತ್ತೆ. These are called as carbon brushes. ಏನಂತಾರೆ ಓಕೆ?
Carbon brushes.
Carbon brushes.
ಯಾವ ಪಾರ್ಟ್ ಆಯ್ತು ಈಗ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆಯ್ತು, ಆರ್ಮೇಚರ್ ಆಯ್ತು, ಸ್ಪ್ಲಿಟ್ ರಿಂಗ್ಸ್ ಆಯ್ತು, ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್ ಬ್ರಷಸ್. These are the very important parts of this diagram. Just see the working. So what is electric motor? Electric motor is a device. Write down. Barcode read electric motor. Electric motor is a device that converts. Electric motor is a device that converts electric energy to mechanical energy. Electric energy to mechanical energy. Are you all written? Ellaru barkondri?
Sir. Yes, sir. Yes, sir.
Energy to mechanical energy. So ನಿಮ್ಮ ಮನೆಗೆ ಮೋಟರ್ ವರ್ಕ್ ಆಗ್ತಾವಿಲ್ಲ, ಫ್ಯಾನು, ಮಿಕ್ಸರ್ ಗ್ರೈಂಡರು, ಕರೆಂಟ್ ಪಾಸ್ ಮಾಡ್ತೀರಿ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಇಟ್ ಟೇಕ್ಸ್ and it moves ಅಂದ್ರೆ ಏನು? ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ. So let us see the working of it. As they are passing electric current, so rectangular coil, that is the armature, split rings, and these are brushes. Axle ಅಂದ್ರೆ ಇದು ಉದ್ದನ್ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ ಇಲ್ಲಿ. Stationary brushes. Brushes do not move, only rings move. So the current pass ago direction ಕಾಣಿಸ್ತಾ ಇದೆ ಎಲ್ಲರಿಗೂ? Can you see the direction of current?
Yes, sir.
So it is passing through it. Nodri pass agi it gets attracted towards north. ಮತ್ತೆ north ಇಂದ ರಿಪೆಲ್ ಆಗ್ತೈತಿ, ಮತ್ತೆ ಸೌತ್ ಕಡೆ ಡೈರೆಕ್ಷನ್ ಹೋಗ್ತೈತಿ, ಮತ್ತೆ ಅಲ್ಲಿಂದ ರಿಪೆಲ್ ಆಗ್ತೈತಿ. ರಿಪೆಲ್ ಆಗಿ 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 ಏನಾಗ್ತೈತಿ? ಇಟ್ ರೋಟೇಟ್ಸ್. So you can see ಅವರು ಏನು ಹೇಳತ್ತಾರ ಅಂದ್ರೆ, ನಾನು ಹೇಳ್ತೀನಿ ಕೇಳ್ರಿ. What they are telling is, so the current is passing through now A, B, C, D, correct? A, B, C, D ಇಂದ ಹೊಂಟಿದೆ current. A to B, B to C, C to D. So after half of this cycle, it is reversed. Reverse ಆಗಿ D ಕೆಳಗೆ ಬರುತ್ತೆ, C ಈ ಕಡೆ ಬರುತ್ತೆ, A and B goes to the other side. So after every half cycle, the current reverses. Will reverse ಆಗಿ ಈ ಕಡೆಯಿಂದ ಬರುತ್ತೆ. But still, as the carbon brushes are there, they do not reverse. Current reverse ತಗೊಳ್ಳಲ್ಲ. So DC current ಅಂದ್ರೆ ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್. ಕರೆಂಟು ಸ್ಟ್ರೇಟ್ ಹೋಗುತ್ತೆ ಯಾವಾಗ. AC ಅಂತೀವಲ್ಲ, ಮನೆಗೆ ಬರೋದು AC, ಆಲ್ಟರ್ನೇಟಿಂಗ್ ಕರೆಂಟ್. ಅದ್ರೊಳಗಡೆ ಸ್ಪ್ಲಿಟ್ ರಿಂಗ್ಸ್ ಇರೋದಿಲ್ಲ, 2 ರಿಂಗ್ ಹಾಕ್ತಾರೆ, ಸ್ಲಿಪ್ ರಿಂಗ್ಸ್ ಅಂತ. ಅಲ್ಲಿ ಡೈರೆಕ್ಷನ್ ಚೇಂಜ್ ಆಗುತ್ತೆ, ಒಮ್ಮೆ ಮ್ಯಾಲ್ ಹೋಗುತ್ತೆ, ಒಮ್ಮೆ ಕೆಳಗೆ ಬರುತ್ತೆ. ನಮ್ಮ ಮನೆಗೆ ಬರೋ ಕರೆಂಟು AC. ಇದು ಯಾವಾಗೂ ಫ್ರೀಕ್ವೆನ್ಸಿ ಇರ್ತದೆ, 50 Hz ಫ್ರೀಕ್ವೆನ್ಸಿಯಿಂದ ನಮ್ಮ ಮನೆಗೆ ಬರೋದು. ದ ಬ್ಯಾಟ್ರಿ, ದ ಕಾರ್ ಬ್ಯಾಟ್ರೀಸ್, ಟ್ರಕ್ ಬ್ಯಾಟ್ರೀಸ್, ದ ಸೆಲ್ ಇನ್ ದ ರಿಮೋಟ್ಸ್, ಎವ್ರಿಥಿಂಗ್ ವಿಲ್ ಹ್ಯಾವ್ ದಿಸ್ ಡೈರೆಕ್ಟ್ ಕರೆಂಟ್. ಇದೇ ತರ ಹುಟ್ಟಿದ ಕರೆಂಟ್ ಅದು ಡೈರೆಕ್ಟ್ಲಿ. ಸಿ ಯು ಕ್ಯಾನ್ ಸಿ ನೌ. ಮತ್ತೆ ಡಿ ಕೆಳಗೆ ಬಂತು, ಎ ಈ ಕಡೆ ಬಂತು. ಬಟ್ ಇಟ್ ಡಿಡ್ ನಾಟ್ ಚೇಂಜ್ ದ ಮೋಷನ್ ಹಂಗೆ ಇತ್ತು. So what happens? ಒಮ್ಮೆ ಪುಷ್ ಡೌನ್ ಆಗುತ್ತೆ, ಒಮ್ಮೆ ಕೆಳಗೆ ಹೋಗುತ್ತೆ, ಒಮ್ಮೆ ಮ್ಯಾಲ್ ಹೋಗುತ್ತೆ. ಈ ಕಡೆ ಇದ್ದಾಗ ಕೆಳಗೆ ಹೋಯ್ತು, ಆ ಕಡೆ ಇದ್ದಾಗ ಮ್ಯಾಲ್ ಹೋಯ್ತು. ದ ಡೈರೆಕ್ಷನ್ ಇಸ್ ಚೇಂಜಿಂಗ್ ಬಿಕಾಸ್ ಆಫ್ ದಿಸ್ ದ ಕರೆಂಟ್ ವಿಚ್ ಇಸ್ ಕಮಿಂಗ್ ಥ್ರೂ ದ ಬ್ರಷಸ್. Direction is changed twice, but it is direct current. ಇಲ್ಲಿ generator ದಾಗ ಗೊತ್ತಾಗ್ತದೆ clean and clear ಆಗಿ. The current is coming from here. The current is coming through this direction, and once it goes up and once it goes half cycle ಮೇಲೆ ಹೋಗೋದು, half cycle ಹೋಗೋದು. Till it completes the full cycle, direction changes. So by continuous motion ಏನಾಗುತ್ತೆ, ಫ್ಯಾನ್ ತಿರುಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡುತ್ತೆ. The fan starts rotating. But ನಮ್ಮ ಮನೆಯಲ್ಲಿರೋ ಫ್ಯಾನ್ಗಳೆಲ್ಲ ಇಂಥವು ಇರುವುದಿಲ್ಲ. We have AC fans at our house. Do you have AC fans in your house? ಬ್ಯಾಟ್ರಿಯಿಂದ ವರ್ಕ್ ಆಗ್ತಾವೋ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯಿಂದ ಮನಿ KV ಎಲೆಕ್ಟ್ರಿಸಿಟಿಯಿಂದ ವರ್ಕ್ ಆಗ್ತಾವೋ?
Electricity.
That is AC. So the motors present ಮನೆಯಲ್ಲಿ ಪಂಪ್ ಸೆಟ್ಟು, ನಿಮ್ಮ ಹೊಲದಾಗಿರೋ ಪಂಪ್ ಸೆಟ್ಟು, ಫ್ಯಾನು, ನಿಮ್ಮ ವಾಷಿಂಗ್ ಮಷೀನು, ನಿಮ್ಮ ಮಿಕ್ಸರ್ ಗ್ರೈಂಡರು, ಇವೆಲ್ಲ AC. ಅದ್ರ ಒಳಗಡೆ 2 ರಿಂಗ್ಸ್ ಇರ್ತಾವ. ದಿಸ್ ಇಸ್ ದ ಡಯಾಗ್ರಾಮ್. ದಿಸ್ ಇಸ್ ದ ಏನ್ ಚಿತ್ರ ತೋರಿಸಿದ್ರೆ ಈಗ ಅನಿಮೇಷನ್ ನೋಡಿದ್ರಲ್ಲ, ದಿಸ್ ಇಸ್ ದ ಡಯಾಗ್ರಾಮ್ ಆಫ್ ಯುವರ್ DC. ಅದ್ ಮೋಟರ್ ಇದ್ರೆ ನಿಮ್ ಮನ್ಯಾಗ ಏನಾದ್ರು ಆಟ ಆಡಕ್ ತಂದಿದ್ರೆ ಎಲ್ಲಾದ್ರೂ ಸಿಕ್ಕಿದ್ರೆ ಅದನ್ನ ಒಡೆದ್ ನೋಡ್ರಿ, ಸೊಕಾಸ ಕಟ್ ಮಾಡ್ರಿ, ಕೆಳಗೆ ಮೇಲೆ 2 ಹುಕ್ ಇರ್ತಾವೆ, ಹುಕ್ ತೆಗಿಬೇಕು. You can see what is inside. Same to same diagram. ಅಲ್ಲಿ ನಡಕ್ಕೆ ಏನ್ ರೆಕ್ಟಾಂಗಲ್ ಇತ್ತಲ್ಲ, ಅದ್ರ ಬದ್ಲಿ ಏನಿರ್ತೈತಿ, ಸರ್ಕ್ಯುಲರ್ ಕಾಯಿಲ್ಸ್ ಇರ್ತಾವ, ಫುಲ್ ವೈರ್ ಸುತ್ತಿರ್ತಾರೆ, ಕಾಪರ್ ವೈರ್ಸ್. ಅಲ್ಲಿ 2 ಮ್ಯಾಗ್ನೆಟ್ ಇರ್ತಾವ, ರಿಂಗ್ಸ್ ಇರ್ತಾವ. ಎವ್ರಿಥಿಂಗ್ ವಿಲ್ ಬಿ ಸೇಮ್. If you get anywhere, open it and you can learn from it. So that's it for today. Till electric motor you learned it. So what all the things you should remember is all the diagrams till electric motor diagram ನೆನಪಿರಲಿ, and all the definitions which are given. Right hand thumb rule ನೆನಪಿರಬೇಕು, Fleming's left hand rule ನೆನಪಿರಬೇಕು, and what is solenoid, uses of solenoid, field lines, properties of field lines. ಇವಿಷ್ಟು ನೆನಪಿದ್ರೆ complete chapter easy ಆಗುತ್ತೆ. All right. Still there are some topics to be taken which will be taken in the next class. ಈಗ ತಗೊಳ್ಳೋ, ನಾಳೆ ತಗೊಳ್ಳೋ?
ನಾಳೆ ತಗೋರಿ.
ಈಗ ತಗೋರಿ. ಈಗ ತಗೋರಿ.
ನಾಳೆ
ಈಗ ತಗೋರಿ.
ನಾಳೆ ತಗೋ. ಎಲ್ಲರಿಗೂ ಬೇಕು. Let it be. We'll take that in the next class. Okay. Tomorrow's class. Tomorrow also madam will not take, I think. Again the timing will be 4:30 to 5:30. Maths togotini. Then I will take this physics. Okay then. See you in the next class.
Yes sir. Bye sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Bye, sir.
For today's class, interesting for you?